Hello, everyone. We'll start the class in a few minutes. If you have any questions in the meantime, please use the chat box to ask your questions. And please post the questions in the group setting, like where everybody can see your questions. So, any questions from all of the weeks to now? I think we're in week 4 now. So, if you have any questions so far, I think people are still joining. So I'll just give it another minute or so.
When class on there,
And all of you, please keep yourselves on mute. Harish, see, I can hear sounds from your device. Please keep yourselves on mute so your background noises are not disturbing the entire class. Okay, so I think it's time. I will start the class. Just 1 second. I hope everyone can see my screen. Um, somebody is not muted. Please make sure at the beginning of the class and throughout the course of the class that you are in fact muted. So I'm not getting unnecessary feedback and noise from your device.
4332.
Dhanush Kalapati, can you please mute yourself? I'm seeing somebody has posted a question in the comments. I will come to your question. I have a few questions to discuss in the class first. I will solve those questions in the class, which should clarify your concepts. And based on that, try to solve this question on your own. And if you are not able to, then I'll solve it. Okay. Rishad Jakhetia, I've seen your question. I want you to attempt it yourself. I'm not sure where you got the question from, but wherever you got the question from, I want you to attempt it yourself. But first, I want you to be clear on your concepts, which is why I think you're not being able to solve it.
Ma'am, the thing is, you had solved a similar question in the previous class, and then I attempted this question, which was there in the practice assignment. But my answer is showing it as wrong.
It is in the practice assignment. Okay, I will
Yes,
look at
ma'am.
it. Okay, I have a few questions on expected value, which I want to discuss first. If you attempt those questions, maybe your understanding of expected value will improve. And then if you still have a problem with the question, we'll discuss it in the class.
Sure, ma'am. Thank you.
Okay. Anybody else? Somebody was saying something. Somebody said explain present value formula. I'm not sure which formula this is. Present value in which context? Amrit, Varshini, Rajesh, can you find the whole problem statement or the whole thing in what context you're talking about present value formula?
Ma'am, it's
Some
time and value of money.
Yeah, but I don't think that the formula is within the scope of your course curriculum.
But
I
sir
don't
was
think.
teaching it, ma'am.
Is it in your class? Which slide
Yes,
do
ma'am,
you remember?
in the video.
Yeah, can you tell me which slide and slide number and presentation name? Because I don't think that is in the scope of your.
Just a minute.
You mean the exponential calculation?
Yes, ma'am.
Okay, I will teach you that, but I thought it's not part of your course. Okay, I'll come to that then. Anything else?
No, ma'am. Thank you.
Okay. Once again, where is my screen? Okay, anyone else? Any other questions? Also, if you have these kind of questions, there is a Google form, I think, in which you can submit your questions before the class. I'm not sure if you guys are familiar with it. Because I come to the class preparing something. So if I already know that you have problem with some concept or something, I will keep that in mind and then I'll prepare the questions for the class accordingly. So if you let me know ahead of time, like if you submit it through the Google form or through, there's a Google group also, right, for discussion where I think a lot of you are very active. So in that discussion, it would be good if you share your questions ahead of time, especially if you think they're not like just one line clarity kind of thing. If you want me to solve a question in class, for example, it's good if you share it ahead of time. So I will just structure my presentation according to that so that, I'm able to cover everything in 1 hour, basically. Okay, let's get started. So, sorry, what is this? Where is my screen? Something is wrong. It's not sharing the correct screen. Okay, can you see it now? Can everyone see my screen? Please give a thumbs up if you can see the screen. Okay, I'm guessing the answer is yes. One person has replied, but okay. All right, so let's get started. These are the instructions as always. You can go to menti.com and log in using this code. Okay, so the first question is just a simple game. Okay, you may have encountered this game, but in a slightly different format, maybe different conditions in your exercise or your lectures or something. So just take a few minutes and calculate whatever the question is asking you, which is the expected value of each transaction and what is the total expected value. So the question is giving you two alternatives in a game. Okay, let's call it a game. In this game, there is some action associated with winning 200 rupees, and the probability for that is 0.5. And another action is losing 100 rupees, and the probability for that is 0.5. So now your your payoffs are already explained: win 200, lose 100. So what is exactly the expected value here? And whether we'll come to that, whether you would play this game or not. So can everybody first tell me what is the final expected value of this entire game? You can answer in the chat box. Okay. I think 4-5 people have answered. Good. Now, see, be careful here. You are not starting with anything, right? You're not asked to play the game at a certain, there's no ticket price for the game. The game is just that, you're playing with somebody, some entity, maybe. And this table doesn't describe the conditions or the actions in the game, but there's some action. Say if you win a toss, you choose for heads. If it's heads, you win 100, 200. And if you choose heads and it's tails, you lose 100. Maybe that's the game, right? So in that case, you're not paying to play the game. You're either winning or you're losing. That's all. There's no other give or take in this game. Is this part clear to everybody? Sometimes these things seem very, very obvious, but people kind of tend to overlook it. So this game is not at a price. The game is just you participate in it. And when you participate, one action can lead to winning and one action can lead to losing. So the expected value is, now you see the first action, which is winning. Probability is half and payoff is 200. So final payoff is what? Expected value. P into payoff, which is 100. The second action is loss. So minus 100. Probability is 0.5. So for this action, expected value is minus 50. So the total expected value of the whole game is sum of each expected value of each action, I mean. So 100 minus 50 becomes 50, right? That's the answer. So how many of you got this right? Let's see. Okay, one person wrote minus 50. I'm not sure why. The others, is this part clear to you? How I got the expected value? Yes, no, maybe you can give a thumbs up if you understood. If you have doubts, you can say something. Okay, so I'm assuming you understood this. Now, the next question is, would you play this game or not? And why? Why not? Like, would you play this game? Okay. So all of those of you who were saying yes. So yes, yep, and yep are all yes, basically. Except for one person who I think said no. I think one person. Or 2-3 people maybe who have said no. So all of those of you who are saying yes, and all those of you who are saying no, why would you play or why would you not play? There's no price for the game. That's what I was explaining in the beginning. There is no ticket price for playing the game. You just walk into a stall, maybe at a fair, and you just play. There's no price to pay the game. You're not buying a ticket or a lottery or whatever. So can somebody explain why you would play or why you would not play if you don't want to play? No? Because there must be some rationale, no? Why you want to play or not play. Why would you play or why would you not play? Okay, somebody's answered positive, Evie. Good. Anybody else? Somebody saying money waste. How are you wasting money? Let's give a try. No risky because no prices. I don't know what somebody's trying to say. Chance of profit is high. So, okay, so there is no right or wrong answer here. Only thing I'm asking is, what is your rationale for wanting to play or not wanting to play? And there can be a rationale for both the things, wanting to play and for not wanting to play. So here, somebody's saying, why waste money? But why you're not wasting money? Your expected value is positive, which is 50. So do you want to elaborate why you think you are wasting money? Somebody saying, Janvi, I don't want to lose money. So yes, Oh, sorry, I misread. Yes, since I won't lose money. Okay, good. Anybody else has a different answer? Does anybody want to explain why they will not play it? Some people have said no. So all the no people, no, I'm not interested. All those people, do you want to explain why you don't want to play it? This is an important distinction for understanding the concept of risk. So I'm just going to give you maybe another minute. After that, I'll move forward. If the money for this game, so there is no money for the game. I explained this in the beginning. I explained this multiple times. There is no fee to playing the game. You just walk into the stall and you just play the game. They're not charging you any money for playing the game. That's it. You just walk into a stall, you toss a coin, and either you win or you lose. So there is no charge for playing the game. So can you get anything? What does that mean? Nathan Jacob, do you want to explain your question? You're saying, can you get anything from the games? That's what the game is. Did you understand what the game is? The rules of the game? No, you did not understand. You have to pay attention. I don't mind repeating, but I do mind repeating when people are not paying attention. So I explained the game. You just walk into a stall and you play a game. There are two actions in the game. One is associated with winning 200 rupees, another is associated with losing 100 rupees. And the probability of both is half, winning and losing. So we discussed how we got the expected value. Now the question remains whether you will play the game or you will not play the game, speaking only for yourself, not for the rest of the class. Somebody was saying most people will play. That is not the question. Question is whether you will play or not. Yes. So when you lose, you would be needing to pay 100 rupees. That is a loss. Yes. Next. After that, that's what I'm trying to ask you. So I was waiting for somebody to come up with this because everybody is mostly saying the same thing. So the point remains that in any group of people, there are always going to be people who are very risk averse. That's what we call as risk averse, who will not want to play a game even if there is a small chance of losing something. And here, even though EV is expected value, Nathan Jacob, please wake up. We are in week 4. We have discussed expected value extensively last week also. So the question remains that expected value is, after all, of course, taking all the probability and wins and losses into consideration. So most people will, yes, consider the expected value and decide whether they want to play. But there is always going to be a small subset of people who will be risk averse, who do not like the idea of losing at all, because they'll be like, oh, there's still a 50% probability that I will lose 100 rupees. Why will I want to play a stupid game because I'm going to lose? Because I don't want to lose 100 rupees at all, even if the alternative is that I win something. I may win 200 rupees, but I'm also going to, there is also a possibility that I might lose 100 rupees, and I don't want to do that. So that is the logic here. There is no fee to playing the game, but there is a chance you can lose money. And not most people, but a lot of people may not want to do that. That is what we are explaining or characterizing as risk loving, risk averse, and risk neutral. So there is not like, how risk averse you are or how risk loving you are is not really capturable through certain calculation. But most generally speaking, if a person is willing to place a gamble, any kind of a gamble, even if the expected value is negative, that person is risk loving. If a person is willing to play, if the expected value is 0, that person is risk neutral. And then there is a person who is not willing to play, even if the expected value is positive. Then that person is risk averse. In the most general terms, that is what different behavioral characteristics are as regards risk. Is this clear to everyone? The concept of whether you are risk loving, neutral, averse, etc. Anybody has any questions? Unless you're speaking, please keep your mics on mute. Several people still have their mics unmuted. So I'm guessing no, ma'am, is for my asking no any questions. Okay, great. So Chris, Jonathan, Dhanya, Shri, Ritika, your mics are still unmuted. Can you please mute yourselves? Please be mindful of this one simple thing. Okay, you've not muted yourself, so I have muted you because I don't want to keep dwelling on it. Okay, next. Now let's come to an insurance policy, which is again discussing the concept of risk. Okay. So now this time there is an insurance policy and that policy has a price. Okay. There is a policy which costs 800 rupees. You are paying 800 rupees. Cost 800 rupees means you or the buyer is buying that policy. So you're paying 800 rupees here. So you do have to split each number given into whether money coming to you or money going from you. That's a very simple way of characterizing it. Like you're paying means money going away from you. So minus, right? So it costs 800 rupees and it covers a potential loss of 5,000 rupees, which has a 15% probability of occurring, right? So what is the expected value of buying this insurance for a risk neutral person? Expected value is the question. So I will let you all solve this first. Take a few minutes, try to solve it, and then I will solve it on the iPad. But in the meantime, do attempt it on your own first, because you will understand it much better if you attempt it yourself. Otherwise, you will, um, not think in the right direction. So please solve it, and you can post your answer in the chat. I will just give you 2-3 minutes to solve it, and I will solve it after that. So has anyone solved it? Okay, good. Some people have solved it. Seems a lot of people have the right answer. Okay, good. So let me stop this screen here and let me share my screen here. Can you all see my screen? Okay. So the first thing is price of policy is 800 rupees, right? I'm just capturing all the information which is given to you. Okay. Possible loss is 5,000 rupees, right? Probability of loss occurring is equal to 15% or 0.15. So this much is, I think, just given in the question. I've just written it down from the question, right? So now let's calculate the expected value of the policy. The policy meaning the whole thing, whatever you're paying versus whatever you're gaining, all of that. Now, you're paying 800 rupees. That is the price. So it will be with a minus sign, right? This is when you're buying the policy, what is happening? You're paying 800 rupees, right? Now, when you're buying the policy, what is happening? There is a possibility of a loss, right? But the whole point of a policy is that you avoid that loss, or if at all that loss happens, you recover it. So there is, no sort of, now what do you say? You're avoiding a certain loss of, whatever amount. So that is what? That is you recovering a loss, which means it's a positive thing. You're not facing that loss, or that loss is not, happening, so to say. So this will be with a plus sign. And now this is not like 100% certainty that you're going to lose. Well, if it were 100% certain, nobody will give you an insurance policy for it. There is a chance, and that chance is what? 0.15. So there is a probability of 0.15 of a loss of 5,000 rupees happening. Okay. So this is all the transactions which are occurring. So this is minus 800, and I think this comes out to be a 750. So this comes out to be minus 50. So this is the whole calculation. And this is the final EV. So now what happens when the expected value is negative? Will a risk neutral person buy this policy? What do you guys think? The question is, will a risk neutral person so somebody is saying as it is not that negative, it is still negative. I don't know how much is that negative, but again, it's a subjective call. But based on our discussion just a few minutes back, a risk neutral person buys something or plays a gamble only if the expected value is positive or zero. In the best case scenario, it should be zero or more. So you can see plays a gamble for expected value greater than equal to zero. This is what we just discussed, right? No. So see, Janvi Agrawal is saying they'll want to avoid the 15% chance of losing 5,000. That's not how it works. That's a very subjective call, right? And yes, we understand that a lot of decisions are taken subjectively, not that objectively, but we are talking about the economic framework for now. Like, we're not talking about what one person somewhere might do. 1 second. Okay. Anyway, my point is that we just discussed that a risk neutral person will engage in any transaction or a gamble only if the expected value is zero or more, greater than equal to zero. Here, expected value is negative because you're paying a sum for something which has a very low probability of occurring. Right? You're paying more than what you would lose considering the probability of it occurring. Yes, it leads to expected loss. Donna Wilson has said something which is correct. Okay. Somebody else has said no because it's slightly expensive than the expected loss. Correct. Okay. And so, Pranav, you're saying not that negative. That is again a very subjective way of looking at it. We are only looking at it in an objective way. 0 greater than 0, positive, negative, right? So this is negative, and hence a risk neutral person will not consider buying this policy. Is this clear? Okay, so let's stop here. And let me come back to my questions. Okay, so we've covered this. We've covered this also. Right, now let's come to the St. Petersburg paradox. What does the St. Petersburg paradox tell you? It's sort of like paradoxical to what we have been discussing for the last almost half an hour, but it is an interesting thing. So we should understand it properly before we jump to conclusions. So many people have answered money value alone does not explain human behavior. That is correct. So why do we call it a paradox? Does anybody want to explain what is paradoxical about St. Petersburg game? Does anybody understand that? Does everyone understand the game in St. Petersburg paradox? Are you clear on the game? What is the game in which we're talking about this thing? How many people understand the game? Money doubles in what way? How is, like somebody said, money doubles in this game, but how? In what way is money doubling? Two to the power n. Okay, good. So what is paradoxical? Or let me ask the other way. Is there anyone who does not understand the St. Petersburg paradox? Yes, most people have answered correctly. No, somebody has said in every head you get the money doubles. No, that is not the game. That's why I was asking if you understood what the game is. So how many of you are not clear on what the game is? It's just a coin toss, sorry. But what is the condition for gaining or not gaining something? Okay, I don't think anybody is answering. So let me explain the game first. So let me first explain the game to you guys, because I am not confident that all of you understand the game. Because it's very easy to think you know the game when you actually have misunderstood it. So the game is you get 2 to the power n at nth coin toss if it's the first head. That is the game. That is the full game. So whatever you're explaining, Jani, that is not exactly correct. I will come to that. That's why I was asking if what you understand of the game. Okay, so the question, let me explain the question, what happens in the game. So say suppose in attempt 1, you toss the coin and you get tail and then head. So here this is 1, 2, 3, right? The probability of getting a head in the third try is half the power of 3, right? What is the payoff you get? This is the nth coin toss. N is equal to 3. At n is equal to 3, and toss is equal to head, right? Oh, guys, just trying to solve it. But what is the payoff? Is 2 to the power of 3, right? So expected payoff, let's call as payoff, not expected value, because expected value is something different in this case. Expected payoff is 1 upon 1, I mean half into to the power of 3 into to the power of 3 is equal to 1. Now, say suppose in the next attempt, you get head at the first coin toss. So at n equal to 1, toss is equal to head. Probability of head at n equal to 1, half, right? Payoff is equal to 2. I'm going a little bit fast because I am assuming you understand or you're familiar with all this stuff. What you're not so familiar with is maybe the structure of the game a little bit. So is this part, the probability calculation and all, is this clear to everybody? Or is this also in doubt? Are you guys following what I'm doing here? The difference is that you get paid at whatever number of toss you get the first head. So if you get the first head at the nth coin toss, where n can be anything, you get 2 to the power of n payoff. In attempt 2, you get head at the first coin toss. You toss a coin and you get a head. So that is what n equal to 1. N is what? The first time you get a head if you keep tossing a coin. If you're tossing a coin over and over again, the first time that you get a head, at that point you get paid. And how do you get paid? If it is a head at an nth toss, n can be anything 1, 2, 3, 4, 10, 100, 250, whatever, right? If you get head, the first head at nth coin toss, you are rewarded a money of 2 to the power of n. Is this clear to everybody? This is the condition of the game. That's like the structure of the game. Okay. Now we know from basic probability theory that the probability of getting the first head at n can be anything, is half to the power of n. Because we are not talking about any scenario, we're talking about the first head only, right? Because to get the first head at n, you have to get tail, 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 and then at n, it is head, right? Let me just explain. Example. Say n equal to k. So that means t, 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 n equal to 1, n equal to 2, n equal to 3, n equal to 4, so on and so forth. And you get, and you get a head at n equal to k, right? So the probability of head at, I don't remember the notation, at n equal to k, I'm just writing it in words, is half into half into half, this whole thing to the power of k minus 1 into half. So this is probability of tail in the first toss is also half, probability of tail in the second also half, so on and so forth, up till k minus 1. Here, this is k minus 1. That is all half. And then head at n equal to k, which is half. This is nothing but half to the power of k. Is this probability calculation clear to everyone, or is it confusing? Yes, no, maybe. Are you understanding? Are you not understanding? Do you want more clarity? Okay, good. Now, this is just the probability part. Now, what we're doing in the St. Petersburg paradox is something very interesting. Here, what we're saying is you are compensated 2 to the power of n at toss equal to h first at n. Or you can word it better. At the first toss equal to h at n, whatever way you want to write it. But I think you understood it. I want to remove all this. They're not errors. Anyway, forget the red thing. It's just trying to be intelligent, whereas it is not. So that is the condition. Now, how do we calculate the expected value? Expected value is sum of all possible scenarios in which you can get anything, any transaction is happening. That's how we do a calculation of expected value for any complex transaction. So say suppose there is not a gamble, but maybe some kind of a thing, some kind of a transaction in which there are multiple options, maybe like 15 options of what can happen. So when you're calculating probability, for example, you consider probability of each occurrence, right? For each thing. Similarly, when you're calculating expected value, if you are expecting to win or lose money in say any number of scenarios, you have to consider the net transactional, payoff, expected payoff of all those transactions. So here, what are those transactions? We're considering like infinite scenarios, right? N equal to 1 to infinity. Because we are just saying we are going to keep tossing the coin until you get the first head. And we don't know when you will get the first head. The first head could be whenever, So technically, maybe not infinity, but possibility is that it can go up till infinity, right? We are considering possibilities here. So what we are going to be doing is we'll sum the expected value of each particular transaction across all the possible outcomes in 1 to infinity. So for n equal to 1, expected, let's say payoff equal to 1, n equal to 2, expected payoff equal to 1, n equal to 3, expected payoff again equal to 1. This we just showed here, right? This is what I was showing here, that expected payoff is always, oh, what is wrong? This, I'm selecting this. This is the expected payoff. And I think I didn't calculate it here. Expected payoff is equal to half into 2 equal to 1. Right? So here it is going to be what? 1 plus 1 plus 1 plus 1 plus da, 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 up till infinity, which is nothing but infinity. So basically, what the game says is that you will keep tossing the coin until you get the first head. And at any point when you get a head, you will get 2 to the power of n, based on the nth coin toss. Now, if you are actually, sticking with the game, you are certain to win something. That is the whole point, what we're trying to highlight, that any point where you win the toss or you win, you get ahead, there is no loss in this game. There is always going to be a win. And not just that, the expected value is infinity. Why? Because if you calculate it, 1, 1, 1, 1, 1, it comes out to be infinity. So Rationally speaking, anybody should be willing to play this game, but most people will not be willing to play this game, or they will not be willing to pay a fee to play this game at all, right? That is what the paradox means, that, for a normal person, they will not be able to do this expected value calculation, and even the reward seems a bit far-fetched, right? Like, why should I wait for so long to get ahead, for example? Who knows when I'm going to get ahead? So the reasons can be many, but it's a paradox because this game gives you assured returns. Like there's no scam here, so to say. There's no loss here. And even expected value is not only positive, it's infinitely positive. But a lot of people would not play this game. Is this clear to everyone now? Yes, people will be willing to pay only a small amount, and a lot of people may not be willing to pay any amount at all. So just give me 1 second. I've lost the slides again. Let me find. Any other questions so far? Let me come to this question, which who's posted. My slides, the PPT is not connecting, so let me just solve this question instead. You're offered a game where you pay 100 rupees to flip a coin. Okay, now in this question, I think if it's from practice question, I only probably made it, but I don't remember it. So anyway, I'll solve it afresh. It's a game where you pay 100 rupees to flip a coin. If it's a heads, you win 200. If it's a tails, you win 0. So what is the expected value of the game? How will we solve this? Does anybody want to answer? Make the iPad only. I'm just copying down the question first. I don't have it anywhere. So the question is saying, pay, or let's see, let's write it as fee. Yeah, fee to play the game is how much? 100 rupees. Okay, you're paying 100 rupees to flip a coin. If you win, you get rupees 250. If you lose, you lose 0. You don't lose anything, which means then you are asked expected value of the game. My handwriting is not actually all that bad usually, but this writing on a screen is actually much harder than writing on paper. So yeah, it's a bit additionally bad here. But I hope you're able to read what I wrote. Okay, so let's calculate the expected value. The first of all, you're paying 100 rupees. That is for 100. That is for certain. There is no probability attached to it. So you are anyways paying 100 rupees to play the game. So that is already minus 100 to begin with, for starters, right? Then if you are winning, you win 250 rupees. And it's a coin toss, right? That's what it says. So you toss a coin. So let me go back to the question. Yes, if you flip a coin. If it's heads, you win 200 rupees. Otherwise, you lose like 0, or you don't win, don't lose. So, which means the probability is what? If you're tossing a coin, we are going to assume it's a fair coin. If nothing is given to you, you always assume it's a fair coin. Okay. So it's half into 250. This is the scenario for heads, right? This is the fee. And then half into 0, because you're losing and winning 0 if you win. I mean, if you get a tails. So what is the sum of this? PV is minus 100 plus 125, so equal to 25. Is this the answer? I don't know what is the answer in the practice set. I mean, I know that this is the correct answer, irrespective of what is mentioned, but I'm asking, what is her name? Prisha Jaketia. I don't know what is the answer on the practice problem set. If it is 25, it is correct. Your answer is correct, and the practice set is also correct. If it is anything other than 25, it is wrong.
Okay, thanks.
Yeah, because I don't remember. So what is the answer on the practice set given?
I'm not sure I remember that, but I think the answer I got was 25.
Okay, so if it is this, then you can be happy. If it is something else, then you can just ignore it. Maybe some error in in setting up the questions. Okay. Right. Let me go back to my presentation. Mhm. 1 second. Something is. You can see it now, right? Like on screen. Yeah. Okay. So we finished this. So now these are some questions, which again are, just giving you some practice with concept of risk and probability. So for answers for practice test should be visible to you after the time to submit the answers is over. Aren't they visible to you? I think they should be once the assignment timeline is over. Okay, I will ask the people if they can show you the answers. I thought it was visible to you. So are you sure that once the submission timeline deadline is over, you are not able to see the answer to the questions? For practice questions also? Okay, I will check with the team. If that is not the case, I'll see if they can do that. Okay. Don't have a lot of time left, but we also have only a few questions left, and I think they're kind of your marks should be immediately visible on for the graded assignments. Again, I'm not familiar with the setup for the portal, like I'm not part of that. Your present value calculation, again, I'll have to go back and see to what extent it is explained in the slides, actually. It will take me some time to go through it because I don't know at what level it is explained for you guys. What we do is at PhD level. So the correct answers are visible. Okay, so it's good. Yeah, only practice assignments. Okay, so the graded assignments, you're not getting the answer or your score. Is that the case? Okay, I will check with the team if they can do that. Yeah, so the whoever is asking about the present value formula, so I can discuss it in the next class because I do need at least a few minutes to go back and see exactly in what context and to what extent it is explained to you. Okay, I will just take it up in the beginning of the next class.
Thank you so much, ma'am.
Sure. Okay, so yeah, now let's come to this question. We have like 8 minutes. I think we can solve it. So you're given 4,800 for sure. That is option A. There is another option, which is you have a 50% chance of receiving 6,000 and a 50% chance of receiving 4,000. So if a person is choosing option A, he or she or they, what exactly are they? Are they risk averse, neutral, risk loving, risk indifferent? What category do you think they belong to? And why? Does anybody want to answer this? You can unmute and answer. So answers for graded assignments will always be visible only after deadline. That is the whole point. Some people were saying for practice assignments, answers are also not available after deadline. I don't think that should be the case. You should see both the answers after the deadline. So what is happening here? What is the expected value of the first option? Option A, it's what? Let me see if I can just annotate on this. Oh, that annotation is, I think, on. Let's see. Yeah, I'm not getting the option to annotate on this. Okay, anyway, I'll try that next time. But so in this case, what is happening? The first option is just a certain 4,800. So there is no probability. So for option A, the expected payoff is 4,800. For option B, 50% chance of receiving 6,000 means expected payoff 3,000. And 50% chance of receiving 4,000 means expected payoff 2,000. So the total expected payoff for option B is 3,000 plus 2,000, which is 5,000. So there is an uncertainty in option B. You may get 6,000 or you may get 4,000, right? 50-50 chance. So now if somebody is, but there is no loss. There's just that you may get less amount, or higher amount. But if somebody is opting to choose only 4,800 option, the option A, where there is only one option where you get a certain amount of some value, and that person is definitely risk averse because there isn't even like any loss. But the expected value of, and even the expected value of option B is higher than the expected value of option A. It's just that there is uncertainty between getting 6,000 and 4,000. That means the person is extremely risk averse, actually, not just risk averse. So I think everybody has this right. So I think you guys understand this. We can move forward. Yeah, this is a good question. So in this, in the previous question, the person's risk premium is how much? What about the worksheets in the videos? Will we receive those on? I don't know which worksheets those are. Oops, sorry. There's something wrong with my laptop today. The screen keeps getting unshared. But I think you can still see it on Mentimeter, right? Question. I'm just going to connect it to my iPad anyway, because I think you are not being able to see the screen anyway. Okay, let me share my screen here. So I'll very quickly solve this one. I think after that, we'll probably have to stop. So you obviously understood the risk part, the premium, risk averse, neutral, blah, blah. Now let's solve for the risk premium for this question. So option, you can see my screen, right? This screen, I hope you can see. Okay, so option A was certain payoff of rupees 4,800, right? And option B was 50% chance of rupees 6,000 and 50% chance of rupees, what was it, 4,000 or 3,000? 4,000, right? Just opening the question. 4,000. Okay, so now what we are seeing is they are choosing the option A versus option B. Now, very quickly, as we calculated before, expected value of A is just 4,800. Expected value of B is what? Half into 6,000 plus half into 4,000. So that is 5,000. Now, at what point will a risk averse person switch? to, what do you say, to the other option, let's say. Like what conditions would there have to be for Discover's person to switch from option B to option A? What should option A be, so to say? So what we are seeing is expected value of option B minus expected value of option A, which is certain. Okay, what I think it's also called the certainty equivalent, is equal to 200. That's the difference. That's the total number we are playing with. Let's see, somebody's asking a question. I'm not sure which worksheets you're talking about. These worksheets, I don't know which ones they are. I will check on that. So coming back to this question, at the end of weekly videos, I'm not sure which worksheets they are. I will need to check because I don't think I have set up any worksheets. So the risk premium is the, let me think of how to explain this premium. Risk premium is how much more, money, no, not really how much more money. Risk premium is the amount of risk that that person is sort of unwilling to take. Right now, in this case, the certain amount is 4,800 and the other amount is expected value is 5,000, but it is not certain. So 200 rupees is the total difference between the two, and yet the person is choosing option A. So the risk premium is basically that extra risk, which is, coming along with some extra compensation. So there is 200 rupees which you're getting extra in expected value of B, but there is also a higher risk associated with that. So that is, I think that is probably the way you can explain risk premium. Is this clear to everybody? I know I've not done a very good job of explaining this, but I'm trying to find the right words to explain it. Is this at least the calculation? Is it clear to you? Okay. Okay, good. Let me see if I will be, let me see if I'm able to share the screen. It's not sharing again. Okay, 1 second. Yeah, I think now you can see. This is this thing is glitching actually a lot. I have to restart the presentation on Mentimeter every time. Okay, so I think a lot of people have got this correct, which is very good. Let's go to the next slide. We are actually out of time and we have done this. So let's take 1 minute and see what people come up with. Expected price is how much? It's just asking the expected price, not the value. What is the expected payoff in terms of the price? So that is just from 1/200 into 1,000, right? There's a 1/200 chance, probability is 1/200, amount which you're winning is 1,000. So expected price is 1,000 upon 200, which is just 5. That is it. That's the answer. Okay, so I think this was not very difficult, this question, but I kept this question just to highlight that sometimes the question may not ask you expected value. So you have to read carefully what the question is. Okay, so let's conclude the class here, and the present value calculation what somebody was asking, I will discuss it in the next class. Okay, and in the next class, if you have any questions you want me to solve or any concept which you think might take some time to explain, it would be good if you can post it in your Google discussion group or in the Google form for questions. So I can just budget some time for it in the class and we're not sort of crunched for time. Okay. Okay. Good response, everyone, today. I'm actually very happy with this class. You guys are actually following what we're discussing. Okay. I'll see you in the next class. Thank you.